reduce cost. Now let us start with cell 1 3. If I start with cell 1 3, this one, and after that, if we after identification of the cell, what we need to do, we need an unknown amount here, unknown amount allocated here. As soon as I put unknown amount theta here, so we get allocation 1 3, we put theta here, and then what will be 3 3. Now look at the allocation 3 minus theta. If I am adding theta here, we have to reduce theta from this allocation, so 3 minus theta. Similarly for this loop, this corner loop is like this, so we know this loop is this one. So 6 plus theta and then 1 minus theta in this cell. Okay. So out of all this value, if we look at, this is a positive, theta is positive value, so these two are positive. If I say these two, theta can take maximum 1, because if I put more than 1, this will becomes negative. Okay. So if I cannot get an allocation, negative allocation, so it can take, theta can maximum take values equal to 1. So if I put 1 here, so this value will be 1, this reduces to 2, this will be increased 6 plus 1 7, and this will be 0. Okay. So our new matrix will be, new transportation cost will be, after looking in 1 3, we will get this transportation cost as 2 will be 0, so I am not writing 0, 3 will be, this is same as it is, this is 1, and just one moment. So we will get theta equal to 1, here it will be 1 because this is 6, here it will be 3 minus 2, 3 minus 1 is 2, then this will be 6 plus 1 7, and this will be your 0. Okay. So if I consider this one, so this 0 into 2, 3 into 5 plus 1 into 1, 3 into 5, 11 into 1 plus 5 into 1 into 1, 5 into 7 plus 15 into 2 plus 9 into 1 into 100, and this total cost becomes 10,100. And if you see that initial Vogel approximation method, our solution was 10,200, so it is reduced by 100 rupees. Okay. Now again we consider the same opportunity cost for this one, taking into the all vacant. Now vacant set is 1 1 1 1 1 vacant set, then 1 4 is vacant, 2 1 2 2 2 3, and 3 2 are vacant set. So if I find out all these vacant set, what I am going to get, see that I will have the 2 3 cell with negative opportunity cost. So we consider this one again. So we are not getting the value, least value here. So what we are going to do, again we put this value, this one 2 3. So our loop will be, if I consider this 2 3 will be your loop will be like this. Our loop will be, if I consider plus 1 here, theta here, this will be 1 minus theta, 3 minus theta, and 1 minus theta. So our loop will be this one. Okay. So C2 3 equal to theta, C2 4 equal to 1 minus theta, this allocation, C3 4 will be your 1 plus theta, and C3 equal to 3 minus theta. And again if I look at this, theta can take maximum value 1. So our next value will be equal to, again considering this, we have got 10,100. So putting values here or here, so ultimate, but after that again you see you have got this vacant cell. So we consider this vacant cell again and check whether we have got we have any other cell which will give you reduced cell. So check again optimality test for that table 1 3, what are our cell value, this one, this two, then this two, and this. Okay. This is already, so now these values are occupied 1 2 3 4 5 6, and then vacants are 1 2 3 4 5, these values are vacant. Okay. In this vacant cell again you check the optimality test, cells are found out 1 3 1 4 2 1 2 2 2 4 3 2, and if I say the opportunity test, you see 1 3 has got negative and all other have positive. So what is 1 3? 1 3 is this value. So in this value, that means we need to put something so that cost is reduced. Okay. Again the same thing, we observe this cell with negative opportunity cost, and so there is a possibility of reducing the transportation cost further. So allocating theta in 1 3, if I put theta here, what is my loop? I have loop this loop. Okay. Theta here, 2 minus theta will be here, 6 plus theta, and then 1 minus theta here. Okay. So what we are getting here? So we get C13 equal to theta, C33 we can put 2 minus theta, C31 will be 6 plus theta and 1 minus theta. This is the loop. Loop is your C13 to C33, so C31 and then C11. So the loop is like that. And if I look into this, theta can take their maximum value 1. So our putting theta here, 1 value here in this one, so our next transportation cost will be this one. This will be 0, 1 minus theta, 1 minus 1, 0, this will be 1. Then here 2 minus 1 is 1 and then this is 6 plus 1 is 7. Now the demand condition and supply conditions are also made. 5 plus 1, 6, here 1, 7, 1, 2, 10, here 7, 5, 3, 2, 1, 2, 3, 3 and then 2. So this demand and supply condition are also satisfied. And if I see the total transportation cost, 3 into 5 plus 11 into 1 plus 6 into 1 plus 5 into 7 plus 15 into 1 and 9 into 2 multiplied by 100 gives you 10,000. So if see that this value is the lowest one. Now again you check the remaining vacant cell 1, 2, 3, 4, 5, this vacant cell and see the opportunity cost. And if I see the opportunity cost for now, you see this opportunity 1, 1, opportunity cost is positive 1, 4, 2, 2, 1, 5, 2, 2, 2, 2, 4, 1, 3, 2, 2, all are positive values. So there is no possibility, no more possibility of reducing the transportation cost. So this, the table we have got, the ultimately what we have got this transportation cost. These are the allocation, these allocations are the optimal allocation, and then we can write the solution. What are the solution? Solutions are x12 equal to 5, x13 equal to 1, x23 equal to 1, x31 equal to 7, x33 equal to 1, x34 equal to 2, and if I multiply this one and get the value 10,000. This is our optimal solution and optimal transportation cost. We cannot further reduce from there. So this is how the stepping stone method does. That means we are putting some value, like putting a stone in a vacant position and then find the net opportunity cost, and using the net opportunity cost we allocate in the vacant cells. Okay, and this is called stepping stone method. And the next class we will be doing MODI method or modified distribution method.